And I'm now going to turn it over to Haley.
All right. Well, hello everybody. I'm going to be talking to you about Miscanthus grass today, and basically growing this alternative crop in the Mid-Atlantic, and I'll be focused on the Eastern Shore because that's where I'm at. I'm located in Salisbury, which is in Wicomico County in Maryland. And I want to introduce my the collaborators on this project. Actually, Dr. Sarah Hirsch is the ag agent down in Somerset County, and she is the lead on this project. And then Dr. John Moyle is our poultry specialist here at University of Maryland, and he's also located in Salisbury. So we've all collectively been working on this project, and really Sarah and John started before I did. I only started working here in 2020, so they've been working with this grass for quite a while. Okay, so um, this is just kind of an overview of what this talk is about. I'm going to go over what the need is for an alternative crop on the eastern shore of Maryland. So why we're even, thinking about Miscanthus and these alternative crops. An overview of Miscanthus in case you're not familiar with this grass, which I don't think a lot of people, if you've ever seen it, you maybe don't know how to plant it. And then some of our preliminary research findings with Miscanthus being grown on marginal land, and then some of the results from our 10-acre field trial. Oh, and all of these pictures here are of Miscanthus. So you can see this is a very flooded field where Miscanthus is growing, and you can see some of the aquatic weeds. I think you guys can see my mouse. And then this is an image with the ducks, and geese love the Miscanthus coming in the spring. So you can see it's growing in uh, kind of difficult conditions. So, one of the big problems on the eastern shore of Maryland, and I'm sure in other parts of the mid-Atlantic, that's affecting farmland is the salinization of fields. So, on the eastern shore of Maryland, we are very flat. A lot of areas are only, a few feet above sea level. And what that means is that salt water can intrude um, into a field, and this will happen whenever we get, well, it's happening slowly with sea level rise, but really a lot of the problems are caused by these agricultural ditches that are woven into the landscape. So we have brackish water ditches that are salty, that connect up to the sides of fields. And then during storm events and high tides, that water can intrude up into the field. So, for instance, when we have a full moon and we're close to the equinox, water from those ditches will come up and into the field. And you can see in this drone picture right here, these areas of bare ground up towards the top of the field, that's where there's a high level of salt in this field, where it's becoming basically uh, so salty that you can't grow a normal agronomic crop like corn, wheat, or soybeans. Okay, so this is an article that was published a couple of years ago, talking about the change in our landscape here on the Eastern Shore, or the Delmarva Peninsula. And you can see this is just, they used different spatial um, GIS data to look at um, the salinity level on these different fields. And you can see basically from 2011, where there's just a little bit of purple, to 2017, there is a lot more introduction of salty soils into the landscape. And even I think what people assume when you think of saltwater intrusion is only coastal areas are getting hit, but really because of these series of ditches and agricultural waterways that are adjacent to fields, um, you can have saltwater intrusion in a lot of different areas. So some of the other problems that we're finding that we consider to be uh, to create marginal land or land that farmers no longer are able to farm uh, economically are things like flooding events or long periods of time where you have waterlogging during the growing season. So this is happening in some of our fields with heavier textured soils that are low-lying. And then we really have a tremendous deer problem here on the eastern shore of Maryland. So probably all of you are familiar with white-tailed deer. I think they're a big problem all across the whole mid-Atlantic, but also we have an introduced species of deer called sika deer. And they, I think, originally are from Japan. They're a little bit smaller than white-tailed deer, but they do a lot of damage. They come out in big herds at night. They're nocturnally active, so it's very difficult for farmers to hunt these deer when they're um, intruding on fields, in the dead of night. So um, both of these species are here and having a great time grazing traditional agronomic crops like corn and soybeans. So, what is a potential alternative crop? You can see here, this is another picture of Miscanthus growing in these flooded conditions. So, just a little bit of a background on Miscanthus, or giant Miscanthus as it's called. Um, this is a large warm season perennial grass. It produces roughly twice the biomass of switchgrass, which is really impressive because switchgrass is kind of like the original biofuels crop that we were talking about across the US, but uh, Miscanthus totally out yields it. Um, Miscanthus can grow up to 12 feet tall. You can see if you were to Google Miscanthus on Google image search, this is like one of the first pictures that comes up of this guy um, being dwarfed by Miscanthus because it really does grow up to about 12 feet tall. Um, a single planting lasts for up to 15 years. I can't say that I know how long it lasts here um, in Delmarva because I don't think we've been growing it. Maybe one or two people who have a single field of it have been growing it for 15 years, but we haven't been looking at it for 15 years. So, but we know that it's this perennial grass that lasts a very long time. It could last more than 15 years. Um, and then as a biomass crop, it produces 8 to 12 tons of dry biomass per acre. So it's a really big yielder. So where does this amazing crop come from? Well, it was the product of plant breeding. So this is not this is not a natural crop. I mean, it's the hybrid combination of two different types of miscanthus. So miscanthus was used and is used in the landscape industry as a uh, as a grass to make gardens look beautiful. And these two species here were bred together to create the giant miscanthus that were growing in fields. Now, what I will say about the giant miscanthus is it is a sterile crop, and uh, we don't anticipate it becoming an invasive species because it has non-viable seeds. So the type of hybrid crop that giant miscanthus would fall into is a triploid sterile hybrid. So it's similar to seedless watermelons or bananas in that this form of sterility is very stable because crops that have a 3 count of each chromosome, um, that makes it impossible for the gametes to form viable seeds, essentially. Um, I don't want to go too deep into the genetics, but this is a very stable form of sterility. So why would we grow miscanthus? Uh, well, basically, it's one of very few options you have, I think, on marginal land like this. So we found it to be salt tolerant, flood tolerant, and deer tolerant. And we'll go into um, how we found this. But these are just pictures of it growing in a flooded little ditch kind of condition here, and then growing in a very salty patch in a field. Here's a picture of what Miscanthus actually looks like in the spring in 2021, and then that same field. Uh, I think this is like the same area in February of the next year. So it really puts on a lot of growth in a single over the growing season. Other reasons why we might want to grow miscanthus, it is a very low input crop. And what I mean by inputs are, the resources that you have to put into it, like nutrients. It doesn't require very much fertilizer. You're not having to go across the field and spray it with a lot of different pesticides. So in that sense, it's it's cheap to produce and more fairly environmentally friendly. It can be harvested late in the winter. So if you think about this from a farmer perspective, um, most of the guys I know are rushing to get their corn out of the field so that they can get the soybeans out of the field. And you're trying to do all of this before the first snow or before it gets too cold. And, if you could take some of your land and put it in miscanthus, you harvest that at a totally different time of the year. So you harvest later in the winter, and so you could not rush quite so much, or you'd have fewer fields to manage in the fall, and then you can harvest miscanthus pretty much any time in the winter once it is dried down. And then because it's a perennial crop, you don't need to replant it every single year. So you're also saving money on planting when farmers are usually very busy in the spring. So overall, it's an easy, low input crop. Okay, so this is really the most important question for any farmer is what is the market for it? How much can you make growing this crop? And at least right now, on the Delmarva Peninsula, the market that is pretty much buying all of the miscanthus that I know of that's being grown is being sold to the poultry companies as chicken bedding. So they use this in the poultry houses as the material under that the chickens walk on. So that said, there are a lot of other parts of the country that grow miscanthus. There are other parts of the world that are growing the same species of giant miscanthus, and it's being used or being turned into all kinds of different things. So the potential uses that we have for it are as green materials, paper products, insulation, biofuels. It could be the cellulosic form of biofuels, and then as pellets or briquettes for burning. So I'll show you some of the pictures of different materials that miscanthus gets turned into. So these are what the pellets look like. These are what you would use uh, for a pellet stove, and they are considered more sustainable than like wood pellets because um, they take more carbon out of circulation faster than trees. This is a German company that is using Miscanthus to make different building materials. So you can turn it into insulation, but they're also turning it into like pressed, like uh, what is it called? They sell at Home Depot, kind of like plywood, but
A press board.
use it in all kinds of ways as a more sustainable green building material for people who want to build more carbon neutral type homes and stuff. It's used in paper products. This is a company, World Centric, that is turning it into paper plates and to-go containers. And I think it's in Tennessee where they have a paper manufacturing plant where they're turning Miscanthus into all of these different paper products that, again, are more sustainable than like tree-grown paper products. Another place that you'll find Miscanthus marketed is for hunters. So it actually makes fantastic deer habitat. I know, well, I'll talk more about deer and Miscanthus, but they like it as a bedding material. They like it because it's so dense and it gives them cover. So you can actually find it for sale on these different hunting websites for creating habitat that deer like. It's also marketed to homeowners as a landscaping tool. So if you want a privacy screen or you're not allowed to have a fence in your backyard, but you really don't want to look at your neighbor's backyard because they've got a heap of trash in there, you can plant giant miscanthus, and it is so dense and bushy that you will not have to see your neighbor's yard, at least for most of the growing season part of the year. So. Poultry houses also use miscanthus, and they plant it outside of, or right behind where a fan exhaust comes out, because miscanthus and other grasses like switchgrass, but miscanthus is really good for this because it's so tall. Um, they capture that exhaust, and in that exhaust are things like ammonia from the poultry droppings, and then also just the dust that's coming out of the house. So this is considered a best practice for poultry houses. And then this is what the actual bedding material looks like that the poultry houses are using. You can see they chop it up fairly fine. It's kind of similar to wood chips, but it's not quite as dense. And what the industry really likes about miscanthus is it's very highly absorbent. The inside of the stalk is kind of this like soft, spongy material that really absorbs a lot of moisture. So that's what makes it such a good animal bedding source. So now I'm going to talk to you a little bit about how you actually grow miscanthus, and then we'll go into our research trial and how it's looking on this marginal land. So the way miscanthus is typically planted in a field is with this specialized rhizome planter, and it has to be propagated via rhizome because, again, the seeds are non-viable, so that's the only way to get it in your field. Generally, you would do the planting in spring. And you can do the planting in fall, but you don't want to do that in areas like where we're planting it, where you may have standing water or flooding over the winter. Generally, Miscanthus, it's recommended that you get at least 30 inches of precipitation a year to plant Miscanthus. So it's not recommended to be grown in like really dry areas like the western part of the country. I know that here where I live, I think we get 45 inches of precipitation a year. So that's plenty. I think pretty much the whole mid-Atlantic gets enough rain to grow Miscanthus. The roots can stretch up to 8 feet down into the ground once it's been established. So it is a fairly drought tolerant species once it's established itself after a year or so. This is a picture of the rhizome planting equipment. So it kind of makes these furrows in the dirt and throws the rhizomes down in there. The soil recommendations for growing Miscanthus are it's a pretty big range. It doesn't seem to be very sensitive until you get down to low pHs or fairly high pHs. It grows in a pretty wide range. And then soil texture has been found to contribute a little, has been found to contribute to vigor. So heavier textured soils with more clay have produced higher yields than finer texture than soils that are more sandy and let more water through. So it really does seem to like swampy areas. This is a picture of the harvesting equipment that's used for Miscanthus. It's kind of similar to like a silage chopper. It goes through the field and really chops up the Miscanthus fairly fine. And then you can see here, it gets blown into a truck. And I think, yeah, you can see here, they are on this um, truck here is on like Caterpillar, uh, not wheels, but tracks. Once Miscanthus has been harvested, at least here, it gets baled and kept in a dry place. So when we got started with our Miscanthus trials, I think it was 2019. I can't say that I was a part of this because I didn't work here yet, but Sarah and John went out and to a farmer's field that had been abandoned because of severe saltwater intrusion, flooding, and they just tested a couple of small plots using a couple of rhizomes of Miscanthus and found, hey, it grew in all the plots. So, you know, maybe we could try growing this somewhere else, or you know, maybe this will work on some of our fields that are being taken out of production. So after that initial plot in kind of a small field, um, we decided to we found a collaborator in Dorchester Farms that operates Tudor Farms. And what we liked about this site was it really had all of the problems that we were looking for in a what we would call a marginal piece of land. So this site has tons of deer pressure. I think they grow more deer than crops, or at least they grow the deer better in this site. The saltwater intrusion was really obvious. I mean, there are tidal ditches everywhere, and you can see the damage, as well as intermittent flooding, a lot during the winter, but also some during the growing season. And so the field that we decided to look at for this study had been planted in soybeans from 2016 to 2020, and they had never been able to harvest due to total crop failure for 4 years in a row. So they knew that this field was more or less doomed, you know, in terms of being able to produce the typical agronomic crops of this area, and they were willing to try something new. So before we had any funding, we decided to do another little small field trial experiment where we just tried planting rhizomes using different methods. So we took two different parts of the field. A part of the field that you can see is very salty, and we know it's salty because nothing is growing there. And then this higher, slightly higher ground portion of the field where at least the weeds were growing. Um, and we planted um, using an auger to kind of dig down into the soil, and then we tried a mounded hill method. So we planted 10 of each, 10 rhizomes in each method in the two different areas. And we also took soil samples of both areas. And in the salty part of the field, where even the Phragmites and the weeds aren't growing, the soil salinity, the sodium content was 580 parts per million, whereas on the other part of the field, it was 200 parts per million. And just to give you an idea what that means, soybeans are going to start having a lot of trouble around 200 parts per million. They're going to be crippled by that salt content. They are not going to be able to grow at 580 parts per million. And soybeans are considered more salinity, more salt tolerant than, say, some of the other agronomic crops. So we know that this field is really not suitable for growing most of our typical agronomic crops. This is kind of what the field looked like when the Miscanthus came up in the spring. You can see, well, what we noticed was the miscanthus we planted in the saltier area was slower to emerge, but they eventually did emerge. And what we found was even though, well, we didn't expect any grazing, the geese actually browsed the young soft miscanthus that had just emerged in July. So excuse me, they took a chunk out of a little bit of the miscanthus, but that didn't really hurt it. It came back. It's got that big, thick rhizome full of nutrients. So even though they ate a little bit of the miscanthus when it first came up, it came back and was thriving by the end of the summer. Okay, so later that year, in 2021, we were funded with a Northeast SARE grant. That's a partnership grant between us, the university, and the farmer. And our goal was really just to observe a 10-acre planting of miscanthus over 2 years. And so we started that in August. In September, we took soil samples of the whole field, determined that we didn't have to lime it, and then we used flags, but we also used some GPS to map the field. We ended up, well, the farmer ended up planting two fields, and it's actually more than 10 acres, but we're only observing 10 of those total acres. It was planted in June of 2022. And then we subdivided the field into 20 different subplots of half an acre. And the reason we did this is because the field it's not homogeneous. So some areas of the field are much wetter than other areas. Some of the field is drier. So we wanted to take measurements in these different areas. We used transects down the field for soil sampling, and then we put out 6 soil moisture probe boxes in different areas. So we selectively picked the parts of the field that were wettest, driest, and kind of in the middle so that we would get an idea, okay, how wet does this field get in the wet areas, and then how dry is it in the dry areas and across um, the whole field. So here's our field map. what I have here in the red lines are the transects. Um, these are our 20 different plots, and then the blue squares are 1 meter square plots, or that's the area where we actually took our yield samples so that we could quantify yield at the end of each growing season. So here's what our subplots look like in that first year. So we have these 1 meter square plots that we measured out, and then we put flags there. And you can see this is one of the subplots that has one of the watermark sensing boxes, and we have different depths of the soil that we're monitoring the moisture at. And then we planned to take yield measurements in these same areas in the winter. To actually measure and quantify the amount of deer pressure in this field, we installed wildlife cameras. I'm not going to share all of that data with you, but what I can tell you is there's tons of deer activity in this field. Every time you go out there, you see tracks like this with all of these deer prints everywhere. So um, every time we went out, we monitored for any deer damage that we to see if they've developed a taste for it or if they started to nibble on it. And we've never observed any deer grazing of any kind. So we're satisfied that the deer aren't eating Miscanthus. So yeah, in 2022, we were a little bit worried when the Miscanthus first came up because this is about the field coverage we got in this top left-hand picture here. So you can see this is a sprig of Miscanthus, another sprig, and then a couple more in this plot. But we really only had between 2 and 7 stands, so that would be a single rhizome that had emerged per 1 meter plot for all of our plots. So we were thinking that this field wasn't going to be very productive, was our guess in that first year. But then as the season went on, it started to sort of fill in. This is a picture of me there, I think in March when we were harvesting. So you can see it's starting to fill in. Um, and this is kind of what our plots looked like when we went to harvest. All of this material that you see here on the ground, that is the leaf drop. So you actually harvest the Miscanthus once it's senesced, and during that process of senescing, the leaves fall onto the ground. So you have this buildup of leaf material every single year that's actually going to be adding a lot of carbon back into your soil over time. So, oh, and our yield for the first year, so based on all of these 21-meter square plots, we got an average yield that amounted to 2.8 tons per acre. So we thought that was pretty good because Miscanthus is supposed to yield like a minimum of I think like 6 to 8 tons in a highly productive system, but it never gets to full yield in its first year. So we thought that that was acceptable. This is kind of what the Miscanthus turned out to look like this year. So when it started coming in, or I guess it's not this year, last growing season in 2023, um, it really started to get a lot bushier. This is a picture of our summer intern, Samala, who came out with me to mark our plots. So we had to go out with really big flags this year because we were afraid that we were never going to be able to find our plots in this much, much denser field. So we use these 10-foot flags. And so throughout the growing season, it got a lot bushier. we noticed a lot more growth, except for in areas where there was constant water logging. So only in the areas where there was water on the field every time we went out did we not see improved growth. And then we weeded a path down the transects of the field between all the plots so that we would be able to find the plots and have a path to walk through safely. So that's kind of what it looked like after it was weeded. I will say, this is a challenging site to work at because you get eaten alive while you're out there. This is the vehicle being swarmed with mosquitoes and me hiding after uh, a challenging day of field work. So we went out and harvested, I guess it was last Friday. So this is what the field looked like just a few days ago. You can see the Miscanthus is very bushy, nice and filled in. Um, this is an area of the field that where the water is it's fairly deep in the front of this photo, but even areas where the miscanthus is growing well, there's at least 2 inches of water standing there. This is a picture of what our drier plots look like. So uh, you can see all that leaf litter is building up, but there isn't any standing water on the ground. And then this is what the wetter plots look like. So uh, in this area of the field, like we couldn't put any of our supplies down because it would have gotten wet, like the weed eater. So we had roughly 4 to 6 inches of water in some areas. And you can see the leaves are just floating there. That's how wet it is. The very wettest areas that I've kind of talked about, this is our soil moisture box you can kind of see back here. Um, this plot, really nothing. We have a little bit of growth, but this wouldn't actually make economic sense. If you had a field that stayed consistently this wet, this is in the summer and in the winter, it really wouldn't make sense to plant miscanthus. That's the only area where we're seeing that it's not growing. Okay, so just to give you an idea, this is the path that was weed-eated in July, and this is what it looked like in February. So even though it was cut back, it starts to regrow, but it doesn't get quite as tall as the full season miscanthus got. So we were at least able to follow that path to harvest all of our plots. Um, we had to cut the miscanthus in half in order to be able to bring it home and fit it in my colleague's minivan. This is Sarah cutting it in half. And that is what it looks like all stacked in there. And soon we will, we're going to make sure that it's all dry and then we will weigh every single plot. Um, This is how we had to harvest it. I'll show you this video clip. Oh, you know what? Maybe I won't. Let's see if it'll play. So it's just thick enough that using clippers makes it very difficult to do. So we were using this bladed weed eater um, to go in there and harvest all the stalks. So once she's done, I would gather them all up and we'd bundle them. Okay, so this project is nearly over, at least in terms of the original grant that funded it. We do have a field day coming up, so if you're thinking, this sure seems like a crazy crop, I have to see this, we would love to see you out there. The field day is going to be on February 21st, and I have a little more information in the next slide. Um, We'll be analyzing the yield of all of these plots as soon as it's all dried down. And then, I mean, it should be dry, but we want to make sure that it's absolutely dry. And then we will be surveying farmers about the barriers for them in terms of adopting Miscanthus. So, what kinds of things are preventing people from planting Miscanthus? Okay, so this is our field day. If you want to take a picture of this, feel free. It is an absolutely free event. We will have nutrient management and CCA credits if that's something you need. The only thing I want to make sure that I highlight, which is highlighted here, is that if you're going to come to this field day, we encourage you to bring waterproof boots and or waders because we really want to be able to take people into the field to see this, but you got to be wearing the right shoes for it. So. Um, and I think Shannon will send this out. She can probably send this out with the slides at the end. So just a little summary of kind of everything I've talked about is Miscanthus could be an alternative crop for the Eastern Shore. We definitely need some additional markets, not just poultry bedding, if we want people to really start growing it. It appears to be deer resistant based on everything we've done and all the deer monitoring that we've done with our research. It's highly flood tolerant and also very tolerant to salinity. The yield potential is still unknown, but we're very hopeful that it's yielding almost as well as it would in a normal field, even in these marginal conditions. So, okay, with that, I'd just like to acknowledge the folks that are on this project, including the colleagues I've already introduced, Dr. Sarah Hirsch and Dr. John Moyle. I'd also like to thank Bud Malone, who's been instrumental in this whole process. Bud used to be in extension with the University of Delaware, and he's a big fan of Miscanthus. Bob Fitzgerald, who allowed us to grow Miscanthus on some of his land, and then Tudor Farms, um, Ben Flahart and Josh Knopp for partnering with us on this Northeast SARE grant. So um, with that, I'd be happy to take any questions. This giant QR code here will lead you to a teaching evaluation if you're interested in doing one. And then this is my contact info. I'm just hsater@umd.edu, or you can give me a call. If you want to talk about Miscanthus or want to know any more information, I'd be happy to talk to you. So thank you.
Thank you, Haley. That was great. Yeah, any questions, you guys can ask those there in the chat pod, and we will be sending out the slide set as well as the recording.
Let's see.
It doesn't look like we have any questions, Haley, but her contact's here if you want to get in touch with her directly. And appreciate everyone's time today. Thank you, Haley. That was wonderful.
Yeah, thank you. See you next time.
Yep. Everyone have a great day.
Bye.